Okay, team. 6.5 learning target. I can describe relationships between two quantities. Between two quantities. All right, now 6.5 has these functions where we're relating two quantities, and they're different because we don't always have numbers in these kinds of graphs, and very common our two quantities are time and distance, but distance could be anything. It could be height, it could be water level, it could be, just about anything. Time could be something else as well, but most commonly we're using time and some other variable. And straight lines represent different things. So if the line is going up, that means that a quantity, in this case distance, is increasing at a constant rate. It's increasing consistently at the same rate. If a line is perfectly flat, well, that means one of our quantities isn't changing at all. So this would be somebody or something standing completely still. Time is moving forward, but the distance is not changing. If a line is ever going down, that means the quantity is decreasing. If it's distance, if we decrease all the way to the bottom, we assume it's 0, would mean distance is now 0. Sometimes we also might see different curves. So let's write curves over here. And curves can mean a couple of different things. If your curve is getting steeper, then that means that something is happening at an increasing rate. If a curve gets flatter, then the change in the quantity is happening at a decreasing rate. And here is what I'm talking about. So first example is a curve. Our two quantities are time and temperature in these two different cities. And we can actually split this curve into two different parts, because the first part of what I'm going to assume is a day, looks like the course of a day, the temperature is increasing. So the sun comes up, the temperature is increasing very fast. Now, notice that this curve is getting flatter. It's getting flatter. At the tip here, it would be completely flat, and then the temperature starts decreasing. So this first part, I would say the temperature, put a little star here, the temperature, oh no, I'd spelled temperature wrong. The temperature increases at a decreasing rate. Then the second part here, now our curve, it's going down, so I know the temperature is decreasing, and this line starts off pretty flat, decreasing just a little bit, and then it gets steeper and steeper and steeper, and the temperature starts dropping faster and faster. So the second part of this graph, I would say the temperature is decreasing now. The temperature decreases, but it's happening at an increasing rate. It's decreasing, but at an increasing rate. The temperature decreases at an increasing rate. All right, now Newport, Oregon, on the other hand, we have straight lines. So whatever is happening, I know is happening at a constant rate. And I would split this into three parts this time. There's a 1, a 2, and a 3. Looks like when they start recording the temperature, it's decreasing because it's going down at a constant rate. So that's the first part here. Decreasing at constant rate, decreasing at a constant rate. Then this second bit here, well, the temperature is not changing at all. Time is moving forward, temperature is not fluctuating. We just say the temperature remains constant. Temperature remains constant. And then the last bit here, 3, the temperature is increasing again. It's increasing. And this line is also straight, so it's increasing at a constant rate. Now, the one thing I would point out is this line is definitely steeper than this line, which tells me that the temperature is dropping quite fast here, as opposed to here where this line is kind of flat, so the temperature is not increasing as much over time. I might say this is increasing slowly at a constant rate, okay? Okay, and for the last bit here, I'm gonna recruit the help of my friends Patrick and SpongeBob for these time distance graphs down below. Let's label these axes, time and distance, time and distance. And these will also be time and distance. I'm just gonna put T and D, time and distance. And let's talk about the distance between these two characters that we all know and love. I'm gonna put Patrick over here. I'm gonna put SpongeBob over here. Now I wanna keep track of their distance over time. So let's pretend that SpongeBob and Patrick, they're gonna start off about halfway to each other. And then time's gonna start and SpongeBob is gonna do this. Time starts and SpongeBob moves over to Patrick until he's perfectly side by side with Patrick. He's gonna wait with Patrick. Maybe they enjoy a Krabby Patty and they're gonna stay in the same spot. Then SpongeBob is going to move back away from SpongeBob and then all the way to his house, and then time stops. So in our graph, what that would look like is, and feel free to rewatch that if you need to, when SpongeBob starts, he's about, I don't know, close to Patrick, but not all the way there. I'm gonna put that about right in the middle. SpongeBob is gonna move at a constant rate, so the distance is gonna get smaller then. It's getting smaller because they're getting closer to each other. If they're perfectly side by side, that means the distance between them is 0. They're gonna enjoy a Krabby Patty, so their distance is not gonna change at all. It's gonna stay the same for some time. And then eventually SpongeBob moves away from Patrick and he goes all the way home, far away from Patrick. All right, there's one. Here's another example. Let's say SpongeBob starts side by side with Patrick. Time starts and SpongeBob starts trickling away slowly, 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 slowly at a constant rate. And then picks up the speed, boom, all the way until time is done. I'll show you that again. They're gonna start side by side. SpongeBob's gonna take off at a constant rate, moving slowly, slowly, and then at some point picks up the speed and moves fast. Boom, time's done. The moth requests you pause your video and draw your graph before moving on. Pause the video. In the second example, we see SpongeBob is leaving Patrick, so the distance is increasing at a very slow rate. At some point, SpongeBob picks up speed, takes off really fast, so the distance is increasing constantly, but at a much faster rate, which is represented by the steeper line. And this last one's a little bit tricky. They're gonna start side by side. SpongeBob is gonna take off fast, but then slow down gradually, slower, 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 stop. And once again, pause your video, draw your graph. Pause. In our third example, we see SpongeBob leaving Patrick at a very fast rate, but his speed is decreasing over time. So he's increasing, the distance is increasing at a very fast rate, represented by the steeper curve, and as it gets flatter, SpongeBob's distance is increasing, but at a decreasing rate, we would say.